let's continue now. In the previous segment, we discussed about the refractive index and what it entails, what it means. Refractive index is the ratio of speed of light in vacuum divided by speed of light in a material medium. And we saw that refractive index can never assume a value that is less than 1. That is the lowest value that is assumed by refractive index, which is the speed, which is actually the refractive index of air. 1 is the refractive index of air. As the material becomes denser and denser, the value of refractive index increases. So the denser the material, the higher the refractive index. The less denser the material, the lower the refractive index. Now, we are talking about fiber optics communication. And we talked something previously about core and cladding. In refractive, if we consider refractive index for the case of fiber optics communication, there is something important to note here. It is that the refractive index of the core must be higher than the refractive index of cladding. So if this is a fiber optics cable, on top, in the middle is core, and surrounding medium is cladding. I think the way I'm drawing it here is not proper, because always the core is very small compared to cladding, but we'll make it a little bit larger for elaboration. So if this is our core, let's say this is our core, and the surrounding part is cladding. This is fiber optics core, this is cladding, this is also cladding. In fiber optics communication, for a fiber to be able to confine light and allow light to travel within it, the refractive index of core, if we say, let's say our refractive index of core is N1, while the refractive index of cladding is N2. For fiber optics communication, N1 is always greater than N2. This cannot be otherwise. N1 must be greater than N2. Why is that? This is very important for light to be confined into an optical fiber cable. If this is not met, then possibility of confining light inside the optics fiber cable is impossible. So the refractive index of core must be higher than the refractive index of cladding. Let's move a little bit further. And let's say this is our interface. And we agree that now this is our N2. If this is, or if we are talking about core, it means this, if we call this glass, and this is air. We know if this is our normal, then if we have a ray of light here, it is going to be refracted. This is normal, incident ray, refracted ray. Now, for total internal reflection to happen, it means this ray must come back to the glass. It cannot be allowed to penetrate to go towards air. It is going to be confined within the glass. What we're going to look at further also here is the core and cladding are both made of glass. There are two different glasses of different refractive indices. We cannot afford to just have a glass and air and then light get propagated. No. Both medias must be glass. So the core is going to be glass and the cladding is going to be glass. But the cladding is going to be a glass of a little bit or slightly lower refractive index as compared to the core. And we're going to look at that in the next segment.